Okay, students. So here the Doppler effect in the different cases. Now the seventh case, if the observer is at rest in between the source and the wall, means let us consider here the case here. Let us consider here an observer is standing. So observer is at rest here, and a car it is moving towards the observer. Not actually towards the observer, it is moving towards the right side, right? So here a driver is there. So this car will be the source of sound, because here the driver continuously sounds the horn, and it will travels with the speed of sound will travels with a speed of v with a frequency of f0. Okay, and here let us consider a wall is there. And obviously it will be also at rest, right? So car వచ్చేసి మూవ్ అవుతూ ఉంది నాన్న towards the wall. Observer వచ్చేసి in between the car and the wall మధ్యలో ఉన్నాడు. Now whatever the sound heard by the observer from the car, it is the direct sound. It is the direct sound received by the source. Now let us calculate what is the change in frequency. Since the source it is moving, observer is at rest, right? Doppler effect will take place. So let us see what is the apparent frequency received by the observer. Now let us consider here the car it is moving with a speed of vs, means the source it is moving with a speed of vs. So therefore here in direct sound case, car is the source and it is moving with a speed of vs, whereas the observer is at rest. That is v0 value, it is equal to 0. So therefore what is the apparent frequency received by the observer, and this is the approach case here. So therefore v minus v0 value, it is equal to plus v0, right? First of all I will write the formula here, approach case. So v plus v0 by v minus vs into f0, right? Since it is an approach case. Okay, now so therefore here apparent frequency received by the observer, a direct case, means directly, right? It is equal to v by v minus vs into f0. Right, clear? Okay, now here the sound it is traveling towards the wall also, and then it is reflected, and the reflected sound it is heard by the observer. So what is the frequency of the reflected sound received by the observer, right? Now first of all here let us see what is the frequency received by the wall, and that frequency it is reflected. So here in reflected sound case, so first of all I will calculate what is the frequency received by the wall, right? So let us calculate frequency received by wall. So therefore car will be the source which is traveling with a speed of Vs, and here the wall, it is the observer, and V0 value it is equal to 0 since the wall it is at rest. And here it is an again approach case, the car it is moving towards the wall, so again it is an approach case, so we have to use the upper sign. So the frequency received by the wall, this is the frequency received by the wall, it is equal to what we will get here. Since V0 it is equal to 0, we will have to use the same formula because it is an approach case here. So therefore V by V minus Vs into F0. So this is the frequency received by the wall. Now wall will reflect the sound with the frequency f prime. Is it clear? The wall will reflect the sound with a frequency f here. Clear? Which is equal to V by V minus Vs into F0. Now so here, therefore the observer will receives the sound with a different frequency other than f prime, right, because it is reflected here. So let us see whether it is the same or not. So therefore the apparent frequency received by observer after reflection. So therefore here this is the reflected sound. This is the reflected sound here, right? Okay, now so therefore let us consider the apparent frequency received by the observer. Now in this case here, wall will be the source which is at rest, means Vs it is equal to 0, and observer he is also at rest, means V0 it is equal to 0. So therefore the apparent frequency received by the observer, it is equal to V plus or minus V0. V0 value it is equal to 0 by V minus or plus Vs value it is also 0 into actual frequency. Means what is the actual frequency it is received by the observer here? It is nothing but reflected sound he is receiving. So therefore the frequency of the reflected sound is f prime, means here we have to use f prime. So here V plus or minus 0, V plus or minus 0, so both will be cancelled. So therefore what is the apparent frequency received by the observer after reflection? So after reflection it is equal to f prime, which is equal to V by V minus Vs into F0. So this is the frequency received by the observer after reflection, and this is the frequency received by the observer directly from the source. Is that clear? Okay, so in the direct sound case, the car will be the source, right, and it is traveling with a speed of Vs. Observer is at rest, so V0 it is equal to 0. So therefore what is the apparent frequency received by the observer? Since it is an approach case here, so therefore we have to use the upper sign, V plus V0 by V minus Vs into F0. So therefore what is the apparent frequency received by the observer directly? It is equal to V by V minus Vs into F0. Okay, now we have to calculate what is the frequency of sound received by the observer after reflection. Means after reflection means we have to calculate what is the frequency first of all emitted by the or else reflected by the wall, right? So for that let us calculate frequency received by the wall first of all. So here the car is the source Vs, it is traveling with the speed of Vs, and the wall, it is an observer, V0 is equal to 0. So therefore again it is an approach case, so therefore we have to use the upper sign. The same formula we will get here. Instead of V0 we will use the 0 value. So f prime, it is equal to V by V minus Vs into f naught. What is this one? This is the frequency received by the wall. Okay, and here this frequency, it is reflected by the wall, and this reflected frequency, it is received by the observer, right? So let us see what is the apparent change in the frequency, whether he is receiving the same frequency f prime or is different. So apparent frequency received by the observer after reflection. Clear? Okay. Now here, after reflection, wall and the observer are at rest. So I am using the general formula. The apparent frequency received by the observer, it is equal to V plus or minus V0. It is equal to 0 by V minus or plus Vs. Vs is equal to 0 into the actual frequency. Means what is the reflected sound frequency? It is nothing but f prime. So therefore f prime. So therefore the frequency, apparent frequency received by the observer after reflection is f double prime reflection, it is equal to f prime. So V by V minus Vs into f naught. So this is the frequency received by the observer after reflection. Now let us see what is the change in frequency here. So here we can say that directly here, in the direct case, what is the frequency? V by V minus Vs into f naught. In the reflection case, what is the frequency received by the observer? V by V minus Vs into f naught. So here the both are same. Clear? So directly what he is receiving the frequency of the sound, after reflection also he will receive the same frequency of the sound. So what is the change in frequency then? Number of beats heard by the observer. So number of beats heard by the observer will be 0, right? So therefore here number of beats heard by the observer per second. So delta f, it is equal to f reflection, means frequency of the reflected, apparent frequency of the reflected sound received by the observer, minus apparent frequency of the sound received directly. Clear? Number of beats heard by the observer directly and reflected. So here both are same. So therefore here delta f, it is equal to 0. Means no beats are heard by the observer. Therefore no beats are heard by the observer. Clear? Okay. Okay. Now let us see the next case here in the Doppler effect. If the source is in between observer and wall. If the source is in between observer and wall. Means here, let us consider a car, it is traveling towards the wall. We can take the car, it is moving away from the wall also. So let us consider the car, it is moving towards the wall, and it is the source of sound. It is the source of sound. It will travel with a speed of V, speed of the sound V, with a frequency f0. And here also the speed of the sound is V with a frequency of f0. Right? In all directions the sound will be produced with the same frequency f0, actual frequency, and V with the speed V. Okay. Now let us consider here there is a wall. and observer, let us consider observer is here and he is at rest, right? He is at rest, and here this is a wall here. Now what is the frequency of the sound? What is the frequency, apparent frequency of the sound received by the observer directly, right? In the direct case, means the sound, it is traveling from the source, right, and the source is moving away from the observer, means it is the recede case here. So in direct sound case, so car is the source here and it is traveling with the speed of Vs. What about the observer? Observer is at rest, means observer is at rest means V0 value is equal to 0, right? Now here the observer is at rest and the car, it is moving away from the observer, means it is the receding case. So in the receding case, as we know that we have to take the lower sign. What is the general formula? Apparent frequency received by the observer, it is equal to V plus or minus V0 by V minus or plus Vs into F0. This is the general formula. So here the apparent frequency received by the observer directly, I am writing it as the F direct prime, means this is the frequency received by the observer, right? Apparent frequency. And here, since it is a recede case, we have to use the lower signs, means V minus V0. V0 value is equal to 0. So in the numerator we will get V value here, V by, and in the denominator V plus Vs, right? V plus Vs into F0. So this is the frequency received by the observer directly. Okay, let us consider this is the equation 1 here. Now let us find out what is the frequency received by the observer after reflection, means this sound will travels towards the wall and again it is reflected, and this reflected wave, this is the reflected wave, it is received by the, this is the reflected sound wave which is received by the observer. So here, first of all, let us calculate what is the frequency of the reflected wave here, right? So in reflected sound case here, so initially, so first of all let us find out what is the frequency received by the wall, and then that wall, after reflection, that wall will be the source. Okay, so first of all let us calculate the frequency received by the wall itself. Now here the car, it is moving towards the wall, right? So here the car, it is the source and it is moving with the speed of Vs, and the wall, it is the observer, and V0 value is equal to 0 because the wall, it is at rest. Now here it is the approach case, it is an approach case. If it is an approach case, we have to apply the, in general formula, we have to apply the upper sign. So here, that is apparent frequency received by the observer, it is equal to V plus V0 by V minus Vs into F0. This is the formula we have to use here. So therefore here let us consider F prime is the frequency received by the observer or else apparent frequency with respect to the observer, with respect to the wall, it is equal to, now V naught value it is equal to 0, so V by V minus Vs into F naught. So this is the frequency of sound received by the wall, and now wall will reflects the sound, wall will reflects the sound with the frequency f prime, right, with frequency f prime. So this is the okay. So here wall will reflect the sound with a frequency of f prime. So therefore, what is the frequency of the reflected sound wave? It is nothing but f prime. So this is the sound which is traveling towards the observer, right, towards the observer. And now let us find out what is the apparent frequency, received by the observer after reflection. Is it clear? Okay, right here. Now, so therefore here the apparent frequency received by the observer, the apparent frequency received by the observer is, now in this case the observer and the wall will be the source, of the sound with a frequency of f prime, right, and the observer it is at rest, wall is also the rest. So here in this case wall it is the source, so what is the speed of the source? It is equal to 0, and observer is at rest, so therefore the apparent frequency received by the observer is, here the wall will be the source, and the observer is also at rest. Wall will be the source and observer is also at rest. So therefore observer is at rest means V naught value is equal to 0. So the apparent frequency received by the observer is f double prime, it is equal to V plus or minus V naught, it is equal to 0, by V minus or plus Vs value, it is equal to 0, into, so what is the actual frequency received by the observer after reflection? It is nothing but f prime, so into f prime. So therefore here, so in the reflected case, the frequency of the sound received by the observer after reflection, it is equal, so apparent frequency received by the observer after reflection, it will be V plus or minus V naught, means it is nothing, V plus or minus 0, by V and V will get cancelled, we will get here f prime, which is equal to, what is f prime value? F prime value it is equal to V by V minus Vs into f naught. So therefore after reflection, the apparent frequency of the sound received by the observer, it is equal to V by V minus Vs into f naught. So let us consider this is the equation 2 here. Now here if you observe that this is the direct frequency, apparent frequency received by the observer from the source, which is equal to V by V plus Vs into f naught, and this is the frequency received by the observer after reflection. This is nothing but V by V minus Vs into f naught. Okay, so here there is a change in both frequencies, so there will be a Doppler effect, there will be a number of beats So let us find out number of beats received by the or heard by the observer. Therefore, number of beats heard by the observer is, so delta f, it is equal to frequency of the sound after reflection minus frequency of the sound directly. So delta f, it is equal to frequency of the sound after reflection, the value it is v by v minus vs into f naught minus, in the direct case the frequency of the sound is nothing but v by v plus vs into f naught. So here taking common of v into f naught, delta f, it is equal to v into f naught, we will get here 1 by v minus vs minus 1 by v plus vs. So here number of beats heard by the observer per second, v into f naught into v plus vs minus v minus into minus plus vs by v minus vs v plus vs, means it is in the form of a minus b into a plus b, means v square minus vs square. Now here v and v get cancelled, so therefore delta f, it is equal to v f naught into 2 times of vs by v square minus vs square. So this is the change in frequency received by the observer directly and reflected. Now in this case here again, here speed of the source, it is far less than the speed of the sound. So therefore vs square can be neglected. If vs square it is neglected here, then number of beats heard by the observer, it can be written as v f naught into 2 times of vs by v square. So here v and v get cancelled, so therefore it is equal to number of beats heard by the observer, it is equal to 2 f naught into vs by v. Clear? So number of beats heard by the observer, right? In the now here the source, it is in between the observer and the wall. Suppose the observer is in between the source and the wall, then the number of beats heard by the observer will be 0. But here it is not equal to 0, right? So these are the 7th and 8th cases of Doppler effect. If the observer is at rest in between the source and the wall, and the 8th case is that if the source is in between observer and the wall, right? Thank you.